point, we're talking to other game objects, right? Because we're, through our spawn point, we're getting the position of one game object and we're moving a different game object over to that position. And so we're able to kind of track that. The get position, set position directly translates to this concept of if I enter a portal and I want to teleport over here, we build something that has a trigger on it. When we land on it, it gets the position of our destination and we set the position of the player. We're going to utilize this concept of that during our next project at some point as a key mechanic. As far as game objects go, we're destroying some game objects, okay? Other game objects we might want to start inside our environment, but not necessarily be active. I'm not going to work this through the entire mechanic, but I do want to point out that there is this command which is activate game object. And when we're talking about activating a game object, what we're talking about is this little checkbox right here. I'm going to call this, this is my active cube, okay? When I uncheck this, the game object is not active. It's inside the scene. You can see it's gray. If I select that object and I activate it, it's now active and will run any logic that's assigned to that cube. So this is one way that we could play. This is one of many ways, and we'll look at more sophisticated ways, but this would be an object that if we wanted to trigger the effects of this object or have it come into existence and run whatever logic is on it. For example, if I have this object with a rigid body and I hit play, I can see that object falling through space, right? Well, let me move this back into a more appropriate position. I'm going to borrow this little test cube that I'm using here. In fact, I'll even rename this. This is my test cube, and this is where I was experimenting with, calling global transitions. I can borrow this. Normally, I'll wireframe something, but what we can do is we can activate game objects, and I'll just type in activate. And you can see that under game object is an activate game object. So I'm doing this on the picked up state just so we can see how we can kind of wire all these different actions together of this cube, this first red cube, and I'll use this to debug. Activating the game object, I'll specify a specific game object and I'll set that cube. Now the default state of this cube could be that it's inactive, it's not there, right? Although it's a rigid body and it's there, it has a position, it's just not turned on. Well, we've told it that when we pick up this cube to activate that specific object, and this would be a very simple way to introduce objects that appear based on walking through, a hotspot or creating a pressure plate of some sort. Same thing for creating a milestone, a waypoint, that sort of thing. Now, when it comes to kind of tinkering with all this technology right now, or tinkering with all this interaction, right now we've almost been exclusively listening for on collision enter. Okay, so if I deactivate this just for a moment, and I'll go and I'll bump into this cube, right? Right now this action is not executing because we have this collision event turned off. I'm going to keep that turned off and just kind of show you the difference between a collision and a trigger. There's another state of physics interactions inside Unity. We've been dealing mainly with collisions at this point where we have rigid bodies that collide. If I were to take my test cube and rather than listening for a collision event, if I would listen for a trigger event, we could build a scenario where we pass through this cube without colliding with its colliders, but still register an interaction with the cube. And in order to do this, we have to go identify the box collider of the thing that we want to start using as a trigger, and make sure that we set it as a trigger. So we're checking this in the box collider. And this gives us the ability not to listen to a collision event, but to listen to another physics kind of event, which is very useful. Physics. And I want to listen for a trigger event. Now the two aren't compatible. You're either listening for a trigger event and you're marking its collider is a trigger, or you're listening for a collision event and you're unmarking its collider as a trigger. In this case, I'm listening for a trigger event. Just want to see if I tagged player. I did not. And we'll use the same send event, which is object has been picked up. And I'll hit the play button. Now the difference between when an object is set to a trigger, I can pass through it, okay? I'm able to pass through that object because it has a collider, but we've said that that collider should not be collided with, it should be triggered. If I turn trigger off, I'll bump back into the object. Okay, so I'm bumping into the object. This is not a trigger event. The two are not compatible. Okay, now the advantage of a trigger is that we don't have to do anything, we don't have to interact with the surface. We're not actually colliding with the surface. We can pass through the surface. So what we could do is we could take an object and we'll give it a certain size. I can turn off the mesh renderer. Now the object is still there. And it's a trigger, but it's effectively an invisible object at this point, right, that I can interact with. So I'm listening for a trigger, and we're activating this game object that, potentially could fall on our head at this point. Now I don't see where my trigger is, and hopefully I'll hit it, and I'll know because that object came out of nowhere, and fortunately I didn't get squashed by it, okay? But by setting it as a trigger, we don't have to actually collide. We don't get the physical result of colliding with a collider. And that could be extremely useful. Okay, so I'll turn that back off. The thing to keep in mind, though, with that is that we have to listen explicitly for a collision event or a trigger event. They're not, they're incompatible in terms of one or the other. You'll see, as I demonstrate concepts, you'll see this happen a lot where I kind of layer in some logic and then deactivate it to test different parts of it. So we'll have some actions that are temporarily turned off to experiment with different things. So you'll probably start seeing more and more of this kind of thing as we move forward. One final thing for today that I want to talk about is just this concept of moving platforms. And moving platforms can be a lot of fun and are kind of the backbone for certain kinds of platforming games. And we don't have to use it just for a platform. We can send objects on patrol. And we can do things like if you have something inside your water that you want to treat as a moving danger zone, like maybe you have a shark fin that's kind of traveling through your lagoon. And you want a collider that travels with that you take damage when you're near that, you could use this concept for it. Now, to get an object moving, I'm just going to create a cube, and I'll call this platform. And this platform will move closer to the ground.
Is that one of the platforms going to move back and forth?
We're gonna make a Sure, what's up?
After you finish making the platform, how do you get the character to stay on top of it?
We'll address that. That's a little trickier than it slides out from under him. Yeah, and we'll address that. So this platform right now is a collider, and we're going to move this object in space. There's several different ways to move this platform. The easiest way to move this is with a translate command. And so I'm going to take this platform, I'm going to right click and add a state machine, and I'm going to make two different states ultimately. That's position 1 and position 2. We'll give this a different name later, but this is position 1. So it'll be our starting position. And I'm going to take this object and I'm going to move it in the direction of Z, in its own Z. So what we can do is we can go to transform, and I'm looking for translate. There it is. And so we can move this object in the direction of its own Z, I'll toggle this and just use a hard value of +5. I don't have a sense of how fast that's going to move, but we'll find out in a second. We'll do it 5 meters per second every frame. That is going to probably be pretty fast. Let's evaluate. Hit the play button. Yeah, it's moving pretty quick. Plus, it's too high. I can't jump on it. Okay, so I'll definitely want to slow it down.
Is there a way that you can make it go forward and backward?
Yeah, and we'll do that right now. I'm going to slow it down a little bit, so I'm going to dial this in. I'll send it to 2. Now, I'm moving in the positive direction for position 1. Okay, and like Pete suggested, there's going to come a time when I want it to stop and move back in the opposite direction. So in very simple terms, what I'm going to do is position 1, it starts off and it moves at a constant speed. I'll move it in the opposite direction on another state, but we want to ping pong back and forth between 2 states based on a given amount of time. So what we can do is we can use a wait timer. We can basically build a timer, and the timer we'll use to exit the state. So there is a wait time. So I'm going to add a wait action, and this is an action that has a finished event. Okay, so we wouldn't want to use a finished event necessarily here. We want to build our own custom event. And we can wait a given amount of time. Let's wait 3 seconds. And our finished event is just going to be a simple generic event that we'll reuse on multiple states. And I'll call this next. So we want to go to the next state. I'll right click, add our next transition. I'm going to hold down the command key, which will give us the second state when we drag it out. So I'm saving myself a few clicks. I'm going to call this position 2. And basically we want to do the opposite of position 1. We want to translate in -z. We'll do -2. And I could copy this selected action, go to state 2, paste the action, and just invert this number to -2. And the logic here is that when we're in position 1, we're translating at a rate. We're going to wait 3 seconds in real time before we fire off next. Obviously, we got a little break in our logic, but we'll pass it to position 2, and position 2 just sends it back in -z. Okay, so we have kind of half of our ping pong worked out. It'll move for 3 seconds, and then go back, and now it'll just kind of speed off into oblivion. Right? It's never going to come back until we introduce that wait, that reset that passes it back, so we can create this little ping pong effect. Okay, so here we'll do wait. We'll borrow our reset event of next. We'll do this in real time. Just make sure that this time number jibes. I'll right click and add the next transition, and so now we have this little ping pong effect where our platform moves back and forth every 3 seconds. Okay, now this is a case where position 1 is using a time, position 2 is using time, and it's the same time, and as long as those times are equivalent, it'll basically move back and forth between 2 points. And this is a really good case where we would want to use a variable so that we could change this variable and say, well, really I want this, 5. I want the time that it takes to be 5. If it's a variable, then we could, do things like the player's influence could influence the length or the position of that. That's one way to do the moving platform. I could change this, obviously, from Z. Oops. We'll change this from Z to Y really quickly here. So we'll move up 3, and then we'll move down 3. And then we'll have more of an elevator effect. Okay. Now, right out of the box, we can hop on this elevator. Okay. Oops, I fell off my elevator, but I was on it for a moment. Let me see if I can get back on it. Okay, so I'm on my elevator and I keep sliding off of it just because of my position. It's getting a little bouncing around a little bit just because of my frame rate and I'm recording. you might get a little bit of a bounce in there, and there's some things that we can do to kind of iron that out over time. You're going to discover really quickly that once you start moving these platforms outside of a vertical space, if we're moving this in a horizontal space, we're going to find pretty quickly that if I manage to jump on my platform, let's try that one more time. We'll do +3 on the Z, and we'll do -3 on Z. Obviously got a value sticking in there somewhere. My Y value, for some reason, is not resetting. Now let's see, is it jumping out at anyone? It's saying none here. Just try to toggle this and see if there's a value hiding in there. No, we'll leave it at 0 and see what happens. I have no explanation as to why that was happening. It was moving in a diagonal. I think it retained some of the value information. I toggled this on to force it to 0. If I turn it back off, I'll expect that it kind of works the same. And so goes the nature of programming and logic. If I can manage to jump on this thing, one, it's way too fast. You'll see that I slide right off of this object. The key will be to parent the player to this object. And I can set this up manually and talk to you a little bit about the logic of this. But my player object, if I just drop this right on top of the platform when I hit play, you'll see that the platform slides out. If I can manage to line this up. You'll see that the platform slides right out from underneath it, okay? If I were to take this player and make it a child of the platform, I can still move independently, but I'm riding the platform right now, right? I can still move, although there's going to be a little glitch in that I'm temporarily inheriting the transform position because I'm a child of the platform, okay?
No matter where you moved your player, you'll still be.
Yep, I'm a child, therefore I have to go where my parent tells me to go, right? That's just the rule. So what we can do is we can dynamically create a mechanic that allows us to parent ourselves to the platform when we collide with it, okay? And I won't work through this entire logic, but right now we have one set of logic that moves the platform. And I do want to point out that this is a really rudimentary, basic way to get things to move from position A to B. The best way is to make a waypoint system that utilizes transform move towards. Okay, and I'll turn off my translate. I'll turn off my wait even, and for now, and you'll notice that the move towards, I'll do this just on one side of the object. I'm going to make an empty game object, and I'll move this into a position, and I'll call this object waypoint 1. And of course, we duplicate that and make it waypoint 2 somewhere. And I'll do this on the platform. So rather than using a translate, I would use a move towards. The game object that we want to move towards has a target object, and I'll target object 1. And the finished event is when we get within a certain distance threshold of that object, we could use the next. So now you can see that I get a little debug line telling me that I'm going to move towards that waypoint. So when I hit the play button, I'll move towards that object. My platform will, if I can look at it. There it goes. And now it's moving back based on, you can see this one's using the waypoint method, the other one's just moving translate, which is like a more, less dynamic method. So I'll duplicate waypoint 1, call it waypoint 2, and then on the second position of the platform, we'll turn off translate, we'll turn off wait, and we'll use this move towards, and I'll just point to this using a different method, waypoint 2, and we'll use that reset. Now that we have it pointing to 2 different waypoints, if I can figure out where it's at, it has a speed value that we can influence. The finish distance is how close it is to the object before it considers itself finished. Okay.
So is it always a linear type of move?
For move towards is, yeah. If you wanted a curve, there's some other methods that we would use that would have to do with tweening. There's some tween tools that we would use. There's also some vector path tools that we could use. But in this case, yeah, this logic, it goes from waypoint 1 to waypoint 2. If I can figure out where waypoint 2 is. There it is. Okay, and this is completely scalable. So in other words, if I were to duplicate this and move this into a different position and call this waypoint 3, if I go back to my platform, I have position 1, 2, and 3, I'll just copy a state and paste the state. This would be position 3. It's looking, we'll want to identify the position 3 waypoint, and then say from position 2 go to position 3, and from position 3 go to 1. So we can scale that logic by doing this and pointing to that 3rd waypoint. Now we're going to go to 3 different positions. Okay, the speed, we're going to let it default. Speed's a little crazy right now. Okay. And that's because the move towards is using this speed method of 10. That is something that we would use as a variable, would be the best bet, and then we could just change it over time, and it would apply to everything, okay? The very last thing that I'd like to do is talk about, dynamically parenting the player to an object. So what I'm going to do is I'm actually going to, because I don't want to change the logic of this. This state machine, this FSM, is the movement. This is the movement. This is the logic that controls the movement. And I just named the FSM here. It's also a component. I could have named it here. It's the same thing. I'm going to deactivate that component. So this state machine it's logical. It works. But when I hit the play button, that state machine is not active. So now my platform is not moving. If I can find it. I'm standing on it, so I couldn't find it. Right? It's not moving because I deactivated this state machine. We're going to start introducing multiple state machines on an object by adding a second state machine. And the way that we'll manage this is through this FSM drop-down menu. Okay? So we have a movement state machine. This state machine, I'll go to the FSM tab and I'll name this. This would be our parenting state machine that manages the parenting. I won't go through this whole logic, but I'll just kind of point you in the direction of basically what we need to do is we want to set up a collision, a simple collision detection, just like our cube, where we would have a collision event and it would be on enter. We'll add a state and we'll do another collision event and we would do on exit. So this one is when we collide with it. And I'm just going to look for parent. And we would set the parent of a game object. This would be the logic. So we don't want to set the owner. We want to specify the player. There it is. And we want to parent it to, in this case, we want to parent it to the platform. Okay, so you'll notice that I can test this logic when we drop the player on this. I can find my player, there it is. If I go to the platform, we should, oops, actually I wanted set parent, I got this wrong. Set parent should be over here. We'll get rid of that for just a moment. We'll turn set parent off here. And we'll do, so this is just like the pickup. Get rid of this state. So we have a collision event. Our player is going to land on this, and we can test this really quickly, where it'll end up in this parenting. Hit the play button, and so the result should be that you can see right now the player got parented to the platform. We would now set up the collision event so that on exit we would deparent. Okay, so that would be the logic, and we could do this really fast. We can set parent. We'll exit our collision event first. So on exit, I should have used another transition event, but I'm trying to get through this quickly. We'll come back to state one, which would also set parent, but we would kind of want to undo what we did. So we'll specify the player, and we want to parent it, in this case, to none. There we go. So we should have some logic. Basically, the result is that when we land on the platform, we're a parent. When we jump, we unparent. Okay, so see how that's working dynamically inside the scene? Okay, and now if we applied our movement to that,